Hey guys, welcome. This is our first page of our review packet. Really super exciting. So if you're an at-home online student, I printed off this packet. It's 37 pages long and I put a bunch up front. So please come and grab one. You can, of course, get credit for this assignment if you're printed out at home or if you show work on another piece of paper, like a piece of notebook paper, but it will be very, very helpful if you just come get the packet and or have an ability to print it out. Okay, let's go. Page 1. Given X and Y is a line, right? So that would look like this, X and Y. And they intersect at point A. So another line comes through here and intersects Z and W, and they intersect at point A. Okay, so all we know is that they meet. We don't know if they meet like, and they're really close together and they meet at A, or they're like at a 90. There's not a lot that we know here, okay? We just know that they meet. What conjecture would always be true? So this angle here would change or would be something we don't know, but what we do know would be, okay, so what we do know is that notice we couldn't know that X and Y and Z and W have to be on different lines. So I'm going to pick D. Non-collinear means not, never on the same lane. And so we recognize here, regardless of whether they meet at a 90 or they meet at an acute or an obtuse angle, depending on which angle you're looking at, no matter what, they're not going to be on the same line. So what about the other ones? Well, we see here, if we finish this off, X and Y, Z and W, they would not necessarily be equal. This is saying this has to equal that. No one said that, right? I could put Y here, and this is shorter. We don't know that. AXZ is acute. XAZ is acute. I drew it as acute. XAZ there I drew as a right angle or close to it. So that's another something that we don't know. It says XY is perpendicular. Here I drew them as intersecting, which is all that we're given, and they are not. So that's something that could be true, but we don't know. So notice the only thing we know to always be true is that they can't be on the same line. Question number 2 states the figure RN and PQ intercept to form these angles. All three lines are on the same plane. Based on the figure, what individual statements would provide enough information to conclude that R is perpendicular to P? Okay, so here's a strategy you could use throughout the test. If they see this word not to scale, if they give you a picture not to scale, you can draw it to scale. So let's say if we were given that angle 2 is 90, then that would mean N is perpendicular to P, right? Then it would also give us that R is something over here. So if N is perpendicular to P, would that force R perpendicular to P? That's what they want to know. Is R perpendicular to P? Here we have no. So we're not going to check that. Then the next one says, if they were telling us that angle 6 is 90. Okay, so 6 is between R and P. So new picture, if they told us 6 was 90, then that's R and that's P, and that's exactly what we're looking for. So this would be a yes. What if they told us 6 is equal to 3? Well, just looking at the picture, 6 is equal to 3, but it's something acute. So this one is something you wouldn't know. Just because they're equal, they could both be 70 and 70. So this is a don't know. That's not enough to know that they're perpendicular. What about if they told us angle 1 and 6 were 90? Okay, so if 1 and 6 were 90, we already have that over here in this picture. This was angle 6, this is angle 1. So if 1 and 6 are 90, then N and P are 90. And we're trying to get R and P to be 90. So this would be a no. What if we made 3 and 4 90? Okay, so if 3 and 4 are 90, that forces N making this 90. And that's what we have here. N is perpendicular to P. But that's not what we're looking for. We're looking for R perpendicular to P. So this is going to be a no. Ooh, it happened here. Sorry about that. Must have bumped something. What about 4 and 5 perpendicular? So 4 and 5. 4 and 5. 3. If 4 and 5 were perpendicular, that would make R perpendicular to P, so we're going to put a yes on that one. Yes, that would actually totally force. Here would be angle 4, here's angle 5, and that would force that to be 90. Well done, guys. Okay, question number 3. Which of the following is true about points on the number line? So let's quantify each of these just by our bunny hops, right? 1, 2, 3, 4. So this is 4. So wherever we see the letter AB, segment AB is 4. BC, 1, 2, 3, right? BC. CD is 1. CD is 1. Then it says AC, so 1, 2, 3, 4, 5, 6, 7. AD, that would be 7, 8. BD, let's start back over anyway. BD would be 1, 2, 3, 4. Is that everybody? Okay, now we're just going to see if this is a true statement. Is 4 plus 3 equal to 7? Yes. Is 1 plus 4 equal to 3? No. Is 1 equal to a third of 8? No. Well, that's equal to some kind of a decimal, right? Is 1/2 times 4 equal to 1 plus 4 over 2? So the left side of the equation, 4 divided by 2 would be 2, right? And 5 divided by 2, that would be a decimal, 2.5. And 2.5 is not equal to 2, so we're going to say no. Last one is 1/3 times 4 equal to 1 plus 3 divided by 3. So the left side is 4/3 and the right side is 4/3. So that looks like a yes. Well done, guys. Question number 4. It says if ACF is 70. Okay, so if ACF is 70, then we know each of these little ones, 1, 2, 3, we have 4 angles. We know all 4 angles have to add up to 70. That's our angle addition. Okay, now if they tell us, well, what else do we know? We also were told this angle is equal to that angle, okay? And we also know those two angles are 16, so we can put 16 degrees, 16 degrees. Now it says, what would be the angle of BCD? So we're looking for this other angle, and we don't know what it is. It's got 2 arc marks on there. So let's call that X. So far, angle 1 is 16. Angle 2, we don't know. We'll call it X. Angle 3, we'll call X as well, because it's the same measurement. And the fourth one is 16. So we can kind of use algebra here. Subtract 32. 3. And we get 19. Now, we can double check our work. If does 16, if these were 19, does 16 plus 19 plus 19 plus 16 all add up to 70? Yes, it does. Nice work. What is the best description of an acute angle? Okay, so we have a number less than 90 is acute, or excuse me, an angle measurement. An angle measurement at 90 is right or perpendicular, right? And an angle greater than 90 is obtuse. And a number equal 180 is called a straight angle. So just a quick review there. So which one best fits it? An angle measuring more than 0 but less than 90. Yeah, if it's less than 0, that's gonna be weird, right? That's not an angle, so yeah. It's less than 90, but it has to be greater than 0. Okay, name the angle formed by ray BA. So let's make a ray BA. Cool. And then another ray. So we don't know where this other ray is going. It could kind of go in any direction here, right? Who knows? It doesn't really matter, but BC is our other ray. And now look at what we've done here. We've actually drawn an angle, so we could call it ABC, or we could call it CBA, or we could call it, ABC or CBA, or just plain old angle B. So notice how B is either in the middle or B is our angle. So let's look at which one matches. It looks like we've got a match here, ABC, and the other ones are not a match. Nice work on page 1 of our packet.